Okay, hello, good morning. Let's see. I checked my videos. The microphone is a bit low, like the audio. So I try to give it a little bit of gain. So hopefully that helps. So yeah, this is my calendar. um, let's see. Yeah, so I'm going to start stream. Like I'm time boxing my mornings. So the first thing I do every morning is that I dive into like all my notifications. So let's see if I can show it here. So I have like my calendars. I look through the day, what's happening today. Is there anything I need to prepare? Then I go through my linear notifications. Then I go through my GitHub notifications so that I can do PR reviews and stuff. And then I check my email, I check my Notion notifications, and I check my Loom notifications. We use Loom quite a bit at CodeSandbox to inform each other and get feedback. So when I'm done with that, I go into Slack and I do the same there. And when I'm done with that, I'm kind of ready to get working. So I try to spend like especially now, we even though I do a lot of non-coding stuff at CodeSandbox, I also do a lot of coding. So I try to do that a very focused way, which is like after I'm done with all my notifications, I can like relax and spend like an hour or two coding before lunch. So that's what we're going to do together. We're going to share that time together, and hopefully it's interesting. Sometimes maybe it's a little bit boring, but yeah. Anyways, you'll get some insight into what it means to do coding at CodeSandbox. So during the weekend, we started working on some tests for this picture process that's running inside our micro VMs. And I realized something at the end, that we are actually starting and stopping these daemons from multiple places. And we have to make sure that so for example, if the CSS language server tries to stop the formatting, like prettier formatting daemon, it shouldn't stop if it's still needed for JSON or for TypeScript. So we need we need to change the concept of this daemon client, that it doesn't actually allow you to send or start or stop, actually. What we rather do is that we'll need to have yeah, I don't think we need to access the state either. But we can have the event emitter there. Because what we need is a reference counter. So whenever one of these servers needs to use a daemon, they actually call a method something like get reference or something. And on that reference, they will have the ability to start, stop, and send messages, and also access to the state. And then we'll have a reference counter, like how many needs to like how many has started it. So we kind of count that. And then if the last one tries to stop it, then we actually stop it. That's the thing. So references started count or start count. So nobody has tried to start it yet. At least this is how I think about it for now, and let's see how this works out. Let's split this up a little bit. Okay, so what we're going to do, let's just keep all of this private, and we'll need to change the tests as well. But we are going to have a disposer here. So if you dispose, we will actually just stop it. We don't care about what other processes is using it. So this is what we're going to do when the picture process itself is being disposed. We're going to dispose of both the daemons, so we know that they stop regardless of what's using them right now. And then we're going to have a get reference. And this get reference is basically going to return a getter for the state. Let's see. I can use self.state. It's going to allow you to start. It's going to allow you to stop. And the way, oh yeah, sorry. And we are going to basically just track internally for the reference if it has been started, or if it, what was the last call? Was it the start or was it the stop? Has requested start, false. So what we're going to do here, I'm just going to write out the code, because in my mind it's very clear, but we'll see if this is actually how it should work. So if we have requested start, we don't do anything. Well, that's the thing. We should always, like, if you try to start, we should always try to start it. Oh yeah, we need the user here. Yeah. Okay, let's just add it here. So, but we only increase the reference count if we, so if not has requested start, we say has requested start is true, and we'll increase the reference start count, right? So now someone has asked to start this daemon. So we are going to say that that's been requested for this reference, and we increase the reference start count. And if for some reason it has been stopped by, yeah, can that happen? Yeah, that's the question. Are we going to say that, like, is there a scenario where multiple call sites has asked, like, could it stop? No, it probably doesn't make sense to. We should only start it if we. Yeah, like, it doesn't matter. Like, we can just start it. It doesn't matter. This is really just to do the reference counting. It's not about, so if it's already started, like, there's really no chance of it not being started. But maybe it's starting, right? And in that case, you want to return the promise of starting. So I think we should just do this. And then we do if has requested start, we'll set it to false, and we'll decrease the reference start count. And then self.stop. I wonder why these tests are running green. Oh yeah, because I just made them private. Anyways, yes. So the point here is that from the perspective of the reference, it will always run start or stop. But their responsibility is to control the reference count. Yes. So when we actually go and stop, first of all, we need to add a new state here called disposed, so that we actually deal with that state. And we're going to say when we, let's see, when we this stop, then this dot state equals state disposed. Yes. So if case disposed, we are just going to return promise.resolve. Well, we can reject it. Maybe we should reject it. I don't think it matters. Like if you try to stop it and it's disposed, we'll just return promise resolve. If you try to start it and it's disposed, then we should probably reject new error. Daemon for this process name is disposed. Yes, I think so. Cool. Let's try this. So this piece of logic controls the reference count, and then when we try to stop, oh, this is interesting. Actually, we are going to copy this. We are not actually going to run stop here. We're going to do this thing. And we're actually going to set it to disposed immediately. And we're not going to run a promise here, we're just going to send a message of stopping it. Because we're not dealing with anything. God damn it. It's really annoying with this user. So we can at least console.error unable to stop this dot process name during disposing. We could pass the user here, or we could check the current state, but that means we have this complexity of maybe you try to dispose it while we're starting a daemon and stuff like that. Maybe we should deal with that. Yeah, let's do that. Let's do the same approach as if you're stopping it, just to make sure that we actually deal with this correctly. So let's switch on the state. So if it's already disposed, it's okay. Return promise.resolve. If it's starting, we are going to return this state promise, and then when that resolves, we are going to dispose of it. Okay, so we are going to do this. So if it's starting, we like when it, this is the sad thing about, maybe we should pass. Yeah, I think we can improve this a little bit, because the thing about typing this is that now we're in starting, and we know that when this promise resolves that we've moved into started, but the typing doesn't show us that. So we kind of have to do another check on the state, which doesn't make any sense. But we could actually send so let's not do this, but let's do, because this is the actual state. So when we connect, we pass the started state back. Which means this creates so much typing stuff. Okay, let's not introduce that. It's so annoying. So we kind of have to check again. It's really annoying. Started. This annoys me. Oh, by the way, I was going to check something. What was that? I was going to check something. CodeSandbox IO. I did this little experiment. What the hell is happening here? There we go. Did I actually name it? What the hell happened here? Why can't I scroll? That's weird. 6 days ago. Home. All sandboxes. My drafts. I didn't actually save it. Like, I didn't name it. Here we go. Yeah, imperative state machine. 6 months ago? Was this the thing I tried? Yeah, I remembered it yesterday, so I'm just going to... Yeah, this is the thing. So you pass in the state, and then you say on transition, idle saving. Yeah, it has all that stuff. And then you say transition 2 and you give it to full state. It does the state change and it triggers the on transition things. Yeah. Anyways, sorry. This one kind of annoys me because we have to make a decision here. We need the user to stop the process. So maybe we should just pass the user on dispose. Yeah, I think we should just do that because it simplifies. Because then we can just say this state is now disposed, and we'll send we'll execute the command to stop. We don't really have to wait for that. And then, so this is when we're starting. It could also be started, like it doesn't matter. Yeah. So if it's disposed, it's okay. If it's started or starting, yeah, that's the thing. So if it's starting, we're waiting for it to be started, and then we stop it. Just to make sure that we actually stop it, right? And then if it's already started, we'll just do it immediately. Yeah, let's put the stop up here. Let's see. Okay. So if it's disposed, it's okay. If it's starting, we'll wait until you started so that we ensure that the stop actually runs, and then we'll say it's disposed. If it's already started, we just stop it, and we say it's disposed. And then if it's stopping, yeah, well, I guess, god damn it, this is so annoying. Like, how do we actually want this to work? Resolve, reject. So reject. I think we should just do this properly. So we'll reject it, or we'll resolve it. So that when we call stop, we're actually able to say, yeah, and we can even do this. We can do, yeah. Yeah, this is better. But we'll set the dispose state immediately. Dispose and stop. That's the term. So we'll set it to a disposed state. And then here we'll just do then dispose and stop. We don't need any of that. If it's already stopping, we can do return this state promise. I guess we can just dispose and stop again. Yeah, I don't think we care about that. So if no, let's do this properly. So this state, sorry, yeah, this state promise, then yeah, sorry, we'll say this state is disposed, and then we'll just return the promise. Oh yeah, we're changing it there. Stopping promise. Again, as I said yesterday, I have also this thing where this feels like overkill, that we are so explicit about these states, but I think it's like don't feel confident how the daemons work when you call start and then you call stop immediately. Like, does it actually handle that the way it should? Or we can maybe, yeah. I get these urges to like explain conceptually what's actually happening, while it could be like simplified. But the tricky thing is like you have some piece of code that is waiting for it to start. And then if you just suddenly stop it, that other thing will resolve as being started, and it's not started. But I guess it doesn't matter, because you can still just stop it from somewhere else. Yeah, I think I'm completely overdoing this. Like, why not just stop it? Well, I guess that, maybe I'm overdoing it a little bit. Because you do want to make sure. Well, I guess with this introduction of the reference counter, we don't need all these. Well, that's the thing. Like, in our code base, when we start something, like when we start a process, I don't think we're actually using the return promise. Even here, like, we're just starting the thing. So it's like, we never really care about, the only thing we care about is sending. So if we don't care about the process of starting and stopping, maybe we should just do it. But then it's like, what if you're trying to send a message right after you hit start? What we can do is, when you try to send, we can look at the state. If it's actually stopped, we would throw an error. But if it's starting, we would wait until that promise resolves before we send the message. So that's a good thing. Yeah. So I don't. Yeah, I think we can simplify this by not having a stopping. But we definitely need started and does it matter? Oh, let's just like it. Yeah. Again, maybe I'm overdoing it. So if it's disposed, we say that it's okay. If it's starting, we'll wait for it to start. Yeah, that's where I think I'm going wrong. Like, we don't really have to wait. If it's starting, we can just stop it. Like, I guess there is like an edge case of, if you call start and stop, like actually execute the command, start stop immediately after the other, it might not work, right? It might take a little bit of time to start it. So when you try to stop it, nothing happens. It just can't find server, so nothing happens. So that's what I mean. It's like being 100% confident that this will actually do what you expect it to do. Yeah, I should just make that argument. as a comment. This is important because we want to guarantee that what you ask for actually happens. Example being start and stop right after each other. We want to wait for it to actually be started so that the stop. But then you can argue, like, what if you do start, stop, start? Then that wouldn't work. Like, that's not a guarantee that works. So it's like, I feel like I'm this is my biggest struggle writing code, is that I'm like, a lot of developers just does what's needed. They're really good at just, okay, let's just do the minimal effort, which is good most of the time. That's good. But I think like a byproduct of that is that you don't always consider like the next person that needs to dive into it, and like making quick, like implementing like first thought solutions. They are not typically. They are primarily, you come up with that idea primarily because you try to figure out how to make the computer do what you want it to do. But then if you like reiterate it with the goal of like making the next person coming into the code understand what you were trying to do, then you implement it typically a little bit differently. But it can be dangerous because you can overthink things. And this arguably doesn't make it easier to read, but at least it explains all the scenarios that needs to be handled. But the question is, does it actually need to be handled? Fuck. Example means... Yeah, so it's more a question of, do we need to handle the scenario where we are starting the process? Like, they start incredibly fast. Like, it's less than a second. But I don't know if the code would ever try to send a message right after it started. Which means that message wouldn't be handled. Which means we should have a starting state so that we can delay that message until it started. That's why we have starting. And then it's stopping. Why do we have stopping? There's no good reason, at least looking at the code now, that we need stopping. Because when we stop, we don't care. We just stop it. And there's no other logic that needs to know what happens to that stopping. So I think we could easily remove stopping. So the guarantee, yeah, let's do this. We have reason about this now. We want to guarantee messages sent right after start hits the server. Okay, so when we're starting, we are going to wait to send the message until it started. So let's move started up here. Oops. Started is a given, stopped is a given, and disposed is a given. So let's look at that. Yeah. So I think that was my overdoing. It was the stopping part. We don't care about that. Cool. And then state. Yeah, so if it started, we are just going to say yeah, so that's the thing. Like, we don't really know. Oh, there we go. So when we're starting and we do stop, do we then yeah, so no. No, I actually thought through this. Let's just express it as I did it, because it's like we do have it might definitely be possible that two processes are trying to stop it at the same time, and we don't want to like send the stop command twice, right? It probably doesn't matter, but God damn it. We want, yeah, let's not, we want to ensure messages passed during start of the process are sent after it has actually started. Wait, allows queuing messages sent while starting. That's what it does. And this state prevents stopping the process when already stopping. Stopped is of course fine, disposed is fine, and started is fine. So this is why we have these states. Starting is to allow queuing messages sent while starting, and stopping prevents stopping the process when already stopping. That's what it does. But the thing, now we're getting back to the reference count, because that's what messes up my mind. It's like I had an idea of how to implement this, but with this reference thing, this changes, because now you can't start it again, because we have the reference count. That's the thing. That's the whole thing, because now we are going to add I should have done that right away. So the point is, if this dot reference start count is more than 1, then we're just going to return what are we going to return then? God damn it. How do we want that reference count to work? Because we do want to give the same guarantees. Like we want to give, like it's supposed to return a promise, but it depends on its state what that promise should be. Like if two different call sites call start at the same time, we should return the promise of starting it. So that's also, I guess, yeah. So that's also different. It's like we don't need a reference count related to starting it. Like just try to start it. And if it's already started, it just returns that it started. And if it's not started, it should start, right? Because you're asking for it. But it's stopping that we have to deal with. So it's basically if, yeah, reference start count. Yeah, so it's basically a reference count. Or should we call it reference stop count? No, it should be reference start count. So if there are no more references that expects it to be started, so if it's more than 0, then we're going to return promise.result. We're not going to do anything about this. That's the whole point. That's the only reason we have the reference count. It's not related to starting the thing, because that's being handled no matter. It's related to stopping the thing. We shouldn't stop it until all references has asked to stop it. Yeah. Yeah, and I think we should do the same here as we do above. It's just that here we actually wait for it to have started before we dispose it. So we can do that here as well. We wait until it stopped and then we set it as disposed. And then do we have one more? Yeah, we're missing a case. Stopped, I guess. Yeah. Dispose and stop. Do we only have one dispose? No, we have two dispose and stop. Yeah. Cool. Yeah, I think this is how it should work. Now we're dealing with it. So what we need to write tests for now is this get reference thing. We're going to use that instead. So what would happen here is that we have two different servers requesting to start the daemon. And what happens is that basically both of them goes into has requested start, and we'll have a reference count of 2. And both of them tries to start it, while the second will hit it with a starting state. So it will just basically return that promise of starting, which is good. And then if both of them try to stop it, we'll reduce the reference start count by 1, which means the first one who tries to stop it will just get the promise resolve, and then the second one who tries to stop it will actually stop it. So we can comment that. When other references still wants this to run, we just resolve the request for stopping it. Yeah, very interesting. This is a really interesting problem to solve. Anyways, so I believe the only thing we're not actually dealing with now is, we need to be able to send on the reference. So send would be self.send bind to self. Where's the send? So now we just check I guess we can make this async, and we can say and status not. So if it's not started and not starting, wait, we'll do this a little bit differently. So we're going to say if this state is starting, we'll await this state of promise. Okay, so if we're trying to send a message while it's starting, we'll wait for it to start before we go ahead and send that message. Sending a message while starting, we'll queue it. Cool. Okay, let's try some tests for this. Yeah, like again, this could have most likely been written way simpler. Like it depends on how you look at it. It's like we could have a lot of checks, like we could have like is. Yeah, the tricky thing is, so for example, when we started, we want to keep a promise for that. Or we could like explicitly create a queue, like starting queue. That could be like a property. But then that queue is only used when you're starting it. And then you would have like a property called is starting, and then you would check is starting, then add to the queue. But then you would also have like is stopping, and then you would need like a promise for that stopping state so that you would return that. So whoever calls it would know when it's done stopping. And then you would add that as a property, and you would just have a bunch of like Boolean properties and promise properties that's used in different settings. And we just made that very explicit now behind the state. So it's basically the same. It's just that we have this label of disposed, starting, started, and we have better logic. Like with dispose, we switch on the state and we know, okay, so when we dispose, how do we deal with that in these different states? And it's even exhaustive. So if I remove one of these cases, it actually gives me an error. And no, I feel confident that I'm actually explicitly dealing with the different scenarios of handling a dispose. I think this is good. Okay, so let's update the tests we already have. So the thing we need to do is const ref client.get reference, and that reference wants to start. Let's see. And then we can say ref state. Yeah, let's just copy this. Oops. So we're just going to make the tests ref based instead. And that should really just make the tests run as normal. And then we're going to test the new logic. We wrote the disposer and having multiple references. And also testing sending a message. Yeah, by the way, I'm wondering if we're getting any. I just merged. Yeah, we're getting conflicts. I think. Maybe not. What happened here? What happened here? Something bad happened. Something bad happened. What did I change? Okay, so I definitely messed something up here. God damn it. That wasn't good. That was not good. Egentlig ikke. Kan du vente til lunsj? Egentlig om 5 minutter. Jeg må bare gjøre det ferdig nå. Ja. Let's see. We're just going to it's the connect thing. No, sorry, send thing. I'm now sending an actual error here. That's the new thing. So let's just I wonder why it was shown as, does it actually have the change? Send. No, it doesn't have the change. But it was shown as dirty. Yeah, it seems like we have a bug. Let's just reintroduce that thing. Okay, cool. So we are back where we were. The tests are running, which is good. So let's, so this is stopping, starting. Describe references. And references are really related to stopping. So it's basically should not stop when already reference already when other reference expects start. So we have ref A, ref B, and then we'll ask ref A to start the thing, and we'll we can just say await the start, and then it doesn't really matter if ref B has asked it to start. Oh, that's interesting. No, sorry. Wait a minute. Yes, it is interesting. Wow, how the hell would that work? God damn it, this is complicated. So if I haven't started and I just stop, yeah, so here we shouldn't really so if I have, god damn it, this is so complicated. So if I haven't asked for it to start, I shouldn't do anything, right? You have to have asked it to start to allow a reference to stop it. Yeah. So ref A and then await ref. So both of them asks it to start. And then we're going to say ref A tries to stop it. And then we expect the state ref. It doesn't matter. Started. That's basically it. And then we await ref B stop, where we expect it to be, well, basically stopped, since we're waiting for the full stop. Ref B. Okay. Did that work? Looks like it. And should not stop when other references expect start. So what we also want to make sure of is should not change reference reference count stopping when not started. So if we have ref get reference, it doesn't ask for it just asks for a stop. Then we want to make sure that the client, and this is a way to access private properties, by the way, if you didn't know that. You just have to use the brackets. Where is it? Reference start count to be should still be 0. Cool. Yeah, so that's references, and then we have describe disposing, and then we also have describe sending. So test should dispose regardless, should dispose and stop regardless of references. And then should queue send when starting. Those are the things we really want to test. But I think I need some lunch. Lunch Rooney. Yeah. I think so. Yeah, and then I'm going to eat some lunch, and then I'm going to basically just write these two tests. I'm going to just test the experience to make sure I didn't break anything, and then I'm going to wrap up that PR. Maybe we could just... Should I continue the stream? Yeah, let's do that. I'll add like a note here. How do I do that? I think I can add stuff to the screen. No, that's the comments. How do I add that? Oh, text. There we go. I want to add some text. Wow, this is at lunch. Do I have emojis? Nice. Oh shit. Oh, looked like it broke. It didn't. Lunch. There we go. At lunch. I'll add that. Oh, this is nice. Maybe I wonder if it's possible to kind of keep these ones. Background should be black. Can I make it black? Oh, yeah, we are transparent. Oh, transparency. That's cool. Okay, 60%. Can I make it bigger? I can. Save. Woo! That's pretty cool. At lunch. I wonder if I can save that. Anyways, I'm going to mute myself, and then I'll be back in 30 minutes, I think. Okay, see you soon. All right. Let's see if we can wrap this thing up. Should dispose and stop regardless of references. So I guess we can go and create a couple of references. And we'll just start both of them. This is an async test. Yeah, fake system user. Cool. So we'll start both of them and then we're going to dispose of it. In this case, we aren't really able to check the message sending, but we need to do that anyway. So I think yeah, we need to mock. I think we need to mock the, damn it. So we do need to mock the net thing. How would we do that? So net socket, we basically need to connect socket on date. Oh my god, how are we going to test this? How are we going to test this? Socket right. Well, we don't really need... Okay, so what we need from this mock is basically connect and on, which doesn't do anything. Connect just calls the callback. And we need write and end. And then we'll just do a jest function on this to see if it writes the message. Let's try that. Jest mock net socket. So class fake socket. And that class, what did I say? It has an on, which doesn't do anything. It has connect, which takes a port and a callback. Port and a callback. Host and callback. And it's just going to call the callback. And then we have write, and then we have end. So end doesn't do anything. Write should be a jest function. Is that how I do this? No, how do I do this? Oh, I guess equals. Yeah, I think this is how we have to do it. So this is nothing, this is nothing. So this should allow us to check that when we are disposing, oh wait, sorry, it's different. So one thing is mocking that thing, but we also need to mock the what's it called? the exec command thing. No, let's just let's not do that. Let's just override it. So client exec command equals just function. We just want to know if it's being called with the arguments. Dispose, and what we want to know, what do we want to know? If we do a dispose, we want to know that it has called the stop. Dispose and stop. I was wondering if we should just return. Yeah, this is interesting. No, yeah, I think we should do it like this. Okay, so we just need to know that it actually moved to dispose. So we'll await client dispose and then expect client state to be disposed. Oh, yeah, we can look at the ref. Let's just over. Did that work? That didn't work. Oh, of course. Wait a minute. Am I actually? What the hell? Child pro. Oh, sorry. Oh, sorry. I don't need this. Yeah. Of course, we're just saying that it worked. The exec, I forgot about that mock. So we just need to know that it's disposed, and it is. Even though we had these references. And then we have the sending. So let's just copy this. And yeah, okay, I think so we do a ref a start, we do a ref fake system user. It's a little bit weird to pass this user, but we don't know that user when we create the client. Yeah, doesn't matter. And then we try to send a message test. Oh yeah. Args, no args. Text. Okay, so we try to send and what we start promise, and then we await the start promise. This is an async test, and then we verify that the yeah, so again, this is the weird thing. The started is not equal to started throw new invalid test state, which means that we should be able to say, oh fuck, where do we have the socket? Oh, we never, god damn it, we never actually exposed the socket. So how do I mock the socket for one test? And okay, so I guess this is allowed. I have no idea. So we can do like just mock, and then we'll do write mock. So we'll say write mock equals that thing, and then we'll just dispose mock. Can I do that? Maybe I even get it back. Just unmock. Yeah. Net. Okay, it doesn't matter. Like, we're not going to use it for anything else, but yeah. Where's the... Yeah, sorry. So we are going to have this write mock up here. And then we're going to expect... is there like a setup thing? Setup before... Oh. I think I can just do it inside the... I guess there's a chance... How do I do this? Whatever. Oh yeah. Oh, okay, so it does... But how the hell do I... How do I know... Oh, okay. I guess that's the thing. Like, you put it up here, and then you do like just function. Yeah, yeah, and then you kind of you get the mock, and then before, after each, you kind of clear the mock. Just reset, restore. Oh, yeah, restore all mocks. Or before each, I guess. Okay, so before each, we restore all mocks. Is that like available result based on their original value? Okay. Don't need this. Restore all mocks, and then we should be able to say like just get mock, require mock net. But I'm creating an instance. How the hell do I get that instance? This is what I hate about testing when you're not separating side effects. Yeah, good morning. This is what I hate about testing when you do side effects. Like when I say side effects, I mean like pointing to environment specific things. So the net package is specific to the node environment, and now I'm using it in a way that's inaccessible from a test. But if I rather passed in the net package, then yeah, because there's no way for me to get access to this socket. How the hell can I know if it's been sent? So I'm just creating the socket here. How can I access it? I will have to So one easy way to do this that would kind of point to the way I like to do it is that when we construct this, we rather pass in a create socket function. So which just uses the interface for the native net package, and then we just move starting creating a socket outside. So you pass in, so maybe that's even a good thing. So there's just some expectations on how the socket I think we need to do that for the test, because I can't access this. Like I would have to add it as like a fake property, which is definitely ugly. I don't like that. Okay, so we're going to do that. That's how I decide to solve it. So I'm going to say create socket, and that's going to be an instance of a net socket. And then we're rather going to say this create socket. Oh yeah, sorry. Create socket. And then we rather create it over here. Cool. And in our test now, we don't have to mock this thing. We can just, yeah, const, yeah, fake socket. Import type. So we just pass it a fake socket. Fake socket. Fake socket. Fake socket. Oops. And fake socket. Fake socket. Fake socket. Fake socket. Fake socket. And here we don't pass a fake socket. Here we are actually going to Well, we can just return something that acts like we just call it netsocket, but we know that we're only calling connect. Which takes a callback that we're going to call immediately, which fails for some reason. And then we have an on thing, which we don't care about. And right, and oops, end. I'm not sure why it's complaining. Conversion of type. Oh yeah, as. Okay. This would be a number, and this would be a string, and this would be just callback on. Why are you complaining? Oh, sorry, of course. There we go. Okay, so the thing we really care about here is const write mock. It's a just function. God damn it. So we have a write mock here, and then on this stuff we don't really care. Cool. So now we have our fake thing, and we should be able to say something like expect write mock to be called with just write foo, which will probably fail, but let's see. Yeah, but it worked. Ha, nice. I'm just going to copy this. So what do we send? Hello world. Okay, let's. And this is hello world. Cool, that actually worked. So now we ensure that even if we're not started, or we send right after a start, that message will actually be sent. Nice. I think we're done in terms of testing. So the thing we really need to do now is, yeah, we don't need this anymore. We need to test it. So what we're going to do is add another terminal. Can I make this one bigger? Oh, cool. Yeah, it doesn't matter. Let's see. So we need to, yeah, let's see if this actually runs now. Yeah, dispose now. Do I have access to? Ah, god damn it. I don't have access to the freaking user here. This is so annoying. So I guess, how would we dispose when we don't have access? Yeah, this is a little bit unsettling. We basically, yeah, this system user thing is really annoying. yeah, I don't think we actually need it, but we're in a transition there. So what we'll have to do here, we have to check if we have user in this.state, or if we don't have. Does TypeScript understand this? Enable to dispose. This starts process due to invalid state. So that means I should be able to go and grab the user from. No, of course not. Yeah, I think I have to do the opposite. If user in state, then do the thing. Else. Oh. Yeah, it adds some complexity, this thing. Yeah. Passing this freaking user. The test still run. Yeah, so now we just need to, yeah, of course, update the code. So we have our CSS server, which now should actually take oh yeah, that's okay. Prettier formatter stop. Yeah, so this is more the prettier formatter itself. We should not point to the daemon. It should private daemon reference is equals get reference. Get that reference, and then we'll rather say this cool. So we're rather using that reference to go and start and stop the thing. So that will now work for CSS and JSON as well. And for the server. And then we just need to do the same thing for ESLint. This is not going to start and stop the actual daemon. It's going to have a private ESLint daemon reference, which is get reference. And we're going to say we don't need a user there. Cool. And then when we're disposing and everyone's happy. I think. Okay, let's try building it. Oops. Oh yeah. Oh, what the hell? There's something when I click these links, for some reason it opens yeah, this doesn't work very well with the Electron app. Where the hell is it? Daemons test. Oh, we're here. Yeah, so now we don't need that fake system user when we dispose. Cool. Let's go and look at picture agent, and we'll need to run that. I can never remember how to. README. There we go. So that's now running, and now we need test client. I think we can use this one, nostalgic cookies. I think this is something I just oh, I actually did something on this one. Okay, let's drop the recursing HTTP. Wow, that one was slow to boot up. Weird. Did this one also have? Oh yeah, this is also... Okay, I'll try one more, or we'll just use a new one. I just remember having a branch where I just... Yeah, this one's good. Yeah, and local. There we have it. Cool. There we go. I need to restart the thing. Let's pop that out. And let's close this. I don't need this thing. Yeah, and I guess I have to go to the dashboard here. Or maybe not. Let's see what happens. Yeah, let's branch out. Do we have any linting here? Whatever. So if I add rules, no alert, should give an error. Fuck, I broke it. Fuck. It's not working. I wrote all this logic, all these tests, and I fucking broke it. That's amazing. Oh, interesting. No, I didn't break it. It's just, yeah. I wonder why that's popping up all the time. Yeah, I just had to like bump the linter. Like I didn't send a linting message. I just opened the file again. That's interesting. Like we should probably send a linter message when we open. Anyways, so yeah, that's working. I don't think I have an actual formatter here. So I think we should test that as well. We can do that by simply adding, oh my god, I've done this so many times now. ESLint plugin prettier, ESLint config prettier, ESLint plugin prettier, and plugin prettier recommended. Not found. Isn't it called ESLint? What the fuck? Oh, of course. And then we'll add the thingy to the thingy. And then hopefully we'll have formatting. And we did. Cool. Now, next thing is like you see it kind of pops up the linting errors, which is really, really annoying. But there's a reason why it does that. So we'll have to, I think it's because, yeah, you see, like it gives prettier errors. And then when we save, there's I'm not sure what's happening there, but yeah. Cool. So at least it's still running, and that's good enough for me. Use daemon reference implementation instead. Commit and push. Yeah, yarn add, yeah. Let's see. I already have a PR that I created. Let's go and find it. Oh, I guess we can just view PR. Okay, so remove that. Now we stop the daemons when pitcher disposes. As we have multiple servers referencing the same daemon instances, we have to make sure when they start, well, when they stop, that they do not stop the daemon for other servers. This is done with a reference implementation. Added a lot of tests to this. Verify that it is still working. After this PR, I consider the new implementation ready for production. Ta-da! Yeah, so this is really cool. Like if you haven't seen this, you see that I get this open in CodeSandbox automatically. So that's something when you set up, like if you have a repo, you set it up in CodeSandbox Projects, you can, you get like an onboarding instruction for adding adding a GitHub app to your repo, and then we'll automatically inject these links. So, so I'm going to ask Jasper to review this, and if he wants to look at the code or test something, he can just click these links and it opens the running branch with the code and everything. Which reminds me, I want him to be able to test this. Here is a CodeSandbox applications branch connected to this PR. Install with ESLint and prettier. Boom, 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 boom. Okay, let's do a quick check. So we are disposing, we are stopping, we are doing a lot of testing. We have added some comments here. Now queuing messages sent while starting and stopping the process when already stopping. And restart. Yeah, that's not correct anymore. I guess we can quickly fix that. start and stop. Okay, let's just read through in case there are any other changes. So it starts and stopped. We added the creates. We can comment that actually. Improves testability and later allow and can be used for other socket implementations. Yeah, it's yeah, it's basically for testability. Blah blah blah. So we have blah blah blah. Yeah, this thing is like, what if it fails starting? This will break. This will become an uncaught exception. But it's so unlikely to happen. And if it does, it's like something's horribly wrong. Like any problems with this, you can just restart the VM and you're good to go, basically. So yeah, I'm not worrying about that. Okay, so this is basically the same stuff. Now we have this new get reference where if it has not requested a start, we say that it has requested a start, and we change the reference count. So you can ask for start multiple times, but it won't like change the reference start count. And if you try to stop and it has not requested a start, we'll just resolve it. If it has requested a start, we say that it doesn't anymore, and we change the reference count, and then we stop it. This is good. And then when we dispose, we actually do the same check. We go and check what state are we in, so we do the right thing. So we don't dispose until it's actually started. So we avoid like, what if for some reason we dispose it while it's starting, and then it tries to stop it and it can't stop it because it's not been started yet, and so on. Blah blah blah, and here we pass that stuff, and then we use the references instead. Yeah, and there's just using the formatter, ESLint. And this, what's this referencing? The TypeScript server. Yeah. Cool. One thing we can test though, that we haven't tested is, what if I do this alert here? Hey. And we are going to try to restart the language server. You saw that? It blinked? Yeah. Yeah, it still shows. So that's good. Yeah, I feel pretty confident about this. It's really well tested. We are very explicit about dealing with the different states of the daemon. We have the reference implementation so that multiple parts of our code base can use the same daemon without one stopping it and the other once it started and all that stuff. So I think we are going to say to Jasper Rooney, I hope I can certainly see, like for Jasper diving into this code, it's like it's a bit like I'm imagining like myself diving into this code, and it's a bit daunting, especially like exec command and the send, especially like start, stop, and dispose is really nice. Like it's very, very explicit. But like the send thing is pretty, where is it? Where are you? Oh, was it because I didn't change it? Yeah, we can just check it here. So private send. Oh, didn't I put private on send? Oh, this is also private. Send is private. Like looking at this, it's a bit daunting, I guess. I don't know. Let's let Jasper decide on that. So Jasper is a colleague of mine. He's been working on Pitcher for quite some time. Has a lot of ownership in it. He's implemented a lot of stuff. Okay, let's request. We didn't really research the daemons ever. We stop and start. So remove that. Now we stop the daemons when Pitcher disposes. As we have multiple servers referencing the same daemon instances, we have to make sure when they stop that they do not stop the daemon for other servers. This is done with a reference implementation. Added a lot of tests to this, verified that it did still work. Added logic to queue any sending while the daemon is starting. Cool. This is huge. This is huge. What's on my? Yeah, this was not happening today, so I don't actually have anything until 1:30. What should we do? What should we do? I have some tickets, I believe. Maybe we could look into oh yeah. I was thinking we'll actually update the document, but of course it will not. Yeah, let's just think of this as a pure reconnect with a new connection. We're doing something really cool. So when you branch now, you see you kind of zoom out and you zoom back in. But we're going to do something that's seamless. So that when you're on main, you can just start writing code. And in the background, we will actually reconnect you to a branch, which is really interesting. So excited to see that. Renewing file. Yeah, I'm curious about this one. It's when we do code insertions from the IntelliSense, it doesn't understand the context we're doing it. So it basically just does a blunt like insertion. And I think there's like custom logic for this. Just checking my Slack. Won't appear on the follow mode test. Oh. Yeah. Yeah, I think I'm going to stop. I'm going to help out a colleague with some tests. But I'll have something. What the hell happened here? Oh, is it the code cov? Oh, what the hell is happening here? This is not ready for review. What the hell is happening? Oh, ESLint. Eek. God damn it. Let's quickly fix these. My bad. Okay, was that all? Yeah, send. And then we the freaking tests failed. How did the tests fail? Oh, for the same reason. Interesting. And I guess the build also fell.
Hello.
That's a colleague. Okay, but we'll talk more tomorrow. Bye for now.